What you need to bear in mind is the cylinder that you've created with paper. Think about the Pringles can. Think about tins with the wrappers taken off, because your biggest issue is going to be dealing with the curved surface to get the surface area of the cylinder. So when we talk about the surface area, we're looking for ways of figuring out how to calculate it. And it's definitely 2 circles plus the wraparound bit, like the label on the tin of chickpeas, okay? And we need to then get a formula for that. So this label that goes around is the same as that bit on the tin, or in this case, this cylinder. It's the same as the circumference. Circumference equals 2 pi r. So the length of this rectangle bit is 2 pi r. And the height or the width of that rectangle will be the same as the height of the prism. So let's put this into the formulas now. Adding up the different shapes, I'm going to have 2 circles. So 2 pi r squareds. And then I'm going to have a length times breadth, which is this label, the rectangular bit that goes all the way around. But the length is going to be 2 pi r, and the height is going to be the same as the height of the cylinder. What if I used the formula that we were using for rectangular prism and also for triangular prism? That one was 2 times area of the base. So it was 2 times area of the base, but area of the base was pi r squared. So you can see it's going to be exactly like the one I've got on top, plus perimeter of the base. Perimeter of the base, there I've written it there. It is the same as the circumference of the circle, which is the same as that. So it's 2 pi r, and then I'm supposed to take perimeter base times the height of the prism. So actually I've got the same formula written twice. So here we have to learn this off by heart. You of course will get it off by heart if you understand the underlying concepts, but either way, you can get away with it even if you're just learning formulas off by heart. That's also okay. Right, the volume of the cylinder is going to be the area of the base, pi r squared, times the height of the prism. So it's going to be pi r squared h. I'm just going to remind you about that. It's the area of the base times the height of the prism. Okay, let's look at calculating this surface area and volume of the example on the side there. First of all, we're going to calculate it where the cylinder is closed on all sides. Okay, my surface area equals 2 circles, 2 pi r squared, or 2 times the area of the base, plus my 2 pi r h. That's going to be 2 pi times the radius. Okay, what is the radius? That 14, the way they've written it, and this can be confusing, the way they've written it in the middle means that it is the diameter. So diameter equals 14, so my radius equals 7. If they put the 14 on just the one side, it would mean that 14 was the radius. But because they put it in the middle, I know that the radius is 7. So 2 pi times 7 squared plus 2 pi times 7, and then the height of the prism is 15. When we use the pi button on the calculator, we're going to find that the answer comes out in pi, which is okay. We end up getting 98 pi over here. And if you do Maths Core next year, you will always be using the pi button, and you will have your answers in pi. We're going to do both in grade 9, so that everybody's got some practice for what they will be doing in the future. So if it was Maths Core, we would leave it like that. But in Maths Lit, we would convert and we would go to decimal and we would have 967,61 square centimeters. We are always going to round off to 2 decimal places. Okay. What about the volume? The volume is going to be pi r squared times h. So that's going to be pi times 7 squared times the 15, which gives us 735 pi. We now need to finish that off, and we need to say that that is 2309,07, and its volume, so it's going to be cubic centimeters. You should round off right at the end of your answer, but if you round off as you go, you must show the rounding off, and that way we can follow your logic all the way through to the end. So the second part of the question was, what if the cylinder's open on top? Well, if the cylinder's open on top, then my surface area will change, but the volume will stay the same. Okay, so the surface area loses 1 circle because it's just going to be open on top, not also at the bottom, like for example a toilet roll. But the volume is going to stay the same because the amount of space it displaces will be exactly the same for the purposes of this conversation. I know that if you think about a cup, which is like a cylinder, and if you think about dipping that into water, it's only going to really displace the amount of volume that is the cup, but we don't have the width of the material that the cylinder is made out of. There will be some application questions like that, but when nothing more is given, this is the way we need to do it. Okay, so we could just take the surface area and subtract a circle, but if I do it from scratch, it would look like this. My surface area would just be 1 circle plus the rectangle. So it would be pi r squared plus, so not 2 pi r squared, just the 1, 2 pi r h. Here I'm using a little h. Earlier I used a big one. It doesn't matter at this point. It's just that when we're dealing with triangular prisms that we need to be aware that they are different. So 7 squared there and 2 pi times 7 times the 15. My answer will be in pi again. It will be 259 pi. And then when I convert that, it's going to be 813,67. The volume will stay the same, and it will still be 2309,07 cubic centimeters.